about functions, okay? This is something that you guys should have learned about in 8th grade, maybe taught a little bit about in geometry. So now we're just going to remind ourselves today what functions are, and then we are going to, as groups, make our own functions, okay? So I'm going to hand these out because this is where you're going to take your notes on this page. So we have an example of a function and not a function. So, I don't know if you remember, but in 8th grade, when you talked about functions, they usually had a rule. And what would happen is you would have this rule, and then things would be input into the function, and you would have an output. Okay? So we are going to watch this video to kind of give you a little example of what a function might look like. It's like a machine that as you input stuff, you have certain things. Okay, so let's go ahead and watch this video. Can all of you guys see it? Okay, so as you see, we have these chickens, and they're being input in a machine, and we are going to get chicken nuggets. Okay? So that is like a function. We're going to input certain things, and then out comes the product, the output. What? What's the output? Yeah. So let's say that we were to put an input chicken and fish nuggets were to come out. Would our machine be working properly? No. So in functions, if you input something and something different comes out than what you expect, like let's say the first time you input chicken and chicken nuggets came out, but then the second time you input chickens and fish nuggets come out, then that means it's not a function. Does that make sense? Because they have to work properly. Okay, let's see what's outside.
Your turn.
What do you expect to come out? Yeah, fish stick. I'll reset it there. Oh, thank Y'all did know that your food comes from actual animals, right? Okay. So what this is talking about is just like businesses created machines to input stuff and output stuff, just like your clothes, right? They input fabric and out comes the shirt that you want. Mathematicians have created a way that we can do this with numbers. And that's what function notation is all about. What are you going to input and what should be the output? Okay? So that's kind of what it's talking about in these words.
That was in his classroom.
Yeah, I used to teach Bruce River.
You taught it? Why?
I was the sort of kid in no, I was just gonna, I was gonna please just teach Bruce River. I was
I
like,
know, because I kept thinking Miss Irwin is the entire time. From the special classes. I'm mad a lot, but.
Okay, so now we're gonna see an actual function machine, not a real machine in Word.
Oh, this is an algebra 1 class.
So as you can see, we input numbers, right? So the number we input is 1, and where does it go? In that Y position or the X position? The X position. So then you did 1, and it came out, and it was 2 times 1. And that was your Y value, okay? So the inputs are X, the outputs are Y. See that? Can even do negative numbers. Because the animal rights people didn't like the original. So what would be the equation? Yeah. So whenever you have a cow equals a cow, the mathematical equivalent for that is y equals x. So whatever number goes in, whatever number comes out. Okay? So that's if nothing happens to the number. What it's saying is they input a lot of things, and the same thing still came out. So now it's going to show you what it might look like when it's more complex. Or when no matter what number you put in, the same thing always comes out, okay? Because we can see that too. And that's still a function. Yeah, where it was all seconds. So now we're going to predict what we think the next machine will do. So, what do we think is going to happen? We just put in a 0. What do you think is going to come out?
Negative 8.
Negative 8. Let's see if you're right. Great job. Okay. 17. Where does this? 9, right? Because it goes in here where the X is. So we input 17 where the X is, and we should get 9. Let's see if we're right. Okay. Negative 3. What? Negative 11, right? Because the negative 3 goes where the X is. We minus 8, and we get negative 11. Woo! Go Haley. So now, we are going to look at the input and see what the output is to determine what the machine is doing. Goes 2 to 4. So we had 2 squared, which is 4. We had 5 squared, which is 25. We had negative 3 squared, which is a positive 9, right? So we can look at the input and the output and figure out the rule. That's probably most likely to happen. Okay, so what did you guys get out of that video? What did it show you about functions? Anything? There are different possibilities of answers, and what determines what the answer is going to be? What you input and the rule, right? So if the rule is x or y equals 7, no matter what you input, it's always going to be 7, right? But if the rule is y equals 2x, then whatever you input will be times by 2, right? So it's the rule and what you input, okay? So that's why we also say that the y value is the dependent variable, because it's dependent on what the x is, okay? So on your notes that I gave you below, let's talk a little bit about functions before we do our project. So I want you to write this on